In this video, I'll show you how to compute probabilities for making statistical inferences. The idea of probability we use when making statistical inferences is based on a frequentist notion of probability, which is a long-run relative frequency. For example, if somebody said that drinking coffee reduces the chance of a heart attack by 1%, this would mean that we had a whole bunch of people, some of whom didn't drink coffee and some who did. Then we computed the percent of each group that had a heart attack. That is, we would divide the number of people who had heart attacks by the total number of people. Let's look at a couple of computations using this idea of probability. Let's start with flipping a quarter. When we flip, it can land on heads or on tails. And let's compute the probability that the coin lands on tails. How would we do this using a frequentist approach? We'd have to flip the coin many times. Then we'd count the number of tails and divide by the number of flips, and in this case, we'd get 52%. So from a frequentist perspective, the probability of a flip of this coin producing tails is 52%. There are two things to keep in mind. First, we're not saying that the probability of the next coin flip being tails is 52%. And we're relying on 100 flips of this coin, but we'd get a more accurate estimate of the probability if we used 1,000 or 1,000,000 flips. Now let's look at another probability question for this coin. What is the probability of getting 47 tails in 100 flips? Pause the video and think about how you might figure this out. For a lot of us, our first instinct is that we'd have to do the same things before, flip the coin 100 times and find the percent of flips that were tails. But if we think about that approach, it doesn't actually answer this question. When we flipped the coin 100 times before, we got 52 tails, and getting 52 tails in those 100 flips doesn't tell us anything about whether or not we would get 47 tails in 100 flips. The key here is to think about the denominator of the probability. Instead of thinking about individual flips, we need to look at many 100 flip sets and then count the number of those 100 flip sets that have 47 tails. So, for example, we would flip the coin 100 times and get 51 tails. Then we'd do another set of 100 flips and we might get 46 tails. Then another set of 100 flips and we might get 53 tails. And we'd keep doing many sets of 100 flips and, to compute the probability, would count the number of those 100 flip sets that had 47 tails. Let's look at another example. Does parental smoking during pregnancy affect the sex of the baby? We could ask, what is the probability of smokers and non-smokers having a girl? To compute this, we could get 500 parents who were smokers, determine the sex of their children, and compute the number of the parents who had girl babies divided by 500. And then we could get 500 parents who weren't smokers, determine the sex of their children, and compute the number of those parents who had girls divided by 500. Now, let's imagine that 51% of the smokers had girls, but only 49% of the non-smokers had girls. That is, there is a difference of 2 percentage points. A question we ask when making statistical inferences is, what is the probability of getting a difference of 2%? I'd like you to pause the video and think about how you might compute this probability. You would start by taking one set of 500 smoking parents and one set of 500 non-smoking parents. But instead of looking at one baby and set of parents at a time, you would look at 500 at a time, and you'd compute the percent of those 500 that were girls. And you wouldn't stop there. You'd look at many, maybe 1,000 sets of 500 smoking parents and compute the percent of each set that had girls. Then you'd look at a set of 500 non-smoking parents, compute the percent that had girls, and then repeat this 1,000 times. In this particular example, the difference between the 52% and the 51% was just 1%, but you'd repeat this 1,000 times and compute the number of sets where there was a difference of 2% divided by the total number of sets you compared. So now we've seen 4 examples of computing probabilities using the frequentist perspective. Some of these computations can feel straightforward, while others are considerably more complicated. And all of these computations are important for helping us make statistical inferences.